Hello Year 12 Single Mathematicians. I'm just going to keep continuing with Chapter 1 in the Year 2 Pure Book, 1.5 Algebraic Division. This is actually something you've done before. It's just examples are a little bit tougher than previous ones, but the method is exactly the same. And the main objective is to be able to perform algebraic long division on what I'm going to coin as improper algebraic fractions. So the first thing I need to remind you of is what the degree of a polynomial is. Now, polynomial is the fancy word for quadratics, cubics, quartics, etc. And the degree of a polynomial is equal to its highest power. So for example, a quadratic has degree 2, a cubic has degree 3, quartic has degree 4, and so on. And an improper fraction, algebraic fraction, has the degree of the numerator is greater than or equal to the degree of the denominator. In other words, top heavy. The highest power on the top is bigger than or equal to the highest power on the bottom. Right. Let's take a algebraic improper fraction then. Call it f of x over g of x. When you perform a division like this and use long division, your answer will look like the following. It is how many times g of x goes into f of x, which is called the quotient, plus the remainder over what you are dividing by. And that's pretty much something you've done before. Now, one subtle difference is in this particular chapter, to disguise the fact you have to use long division, they sometimes ask you to express the answer not in this form, but in the form if I multiplied everything by g of x. So it's just a disguised version of this. They are equivalent to each other. So if I timesed everything by g of x, I would get this. And again, it is just a disguised form of long division. A little bit harder to spot this long division, and that's an exam technique you've got to eventually pick up. So let's have a look at our first example. The following, we've got quartic, so the degree at the top is 4, quadratic, degree on the bottom is 2, so that's an improper algebraic fraction, and we're asked to express in this form, which is the more familiar form. One is a little bit more obvious, where that there would be the quotient, and that there would be the remainder. Okay, so let's do the division. Now remember, in the division, just like in numbers, use the number 0 for any missing terms. So in this quartic, there's a missing x squared, so call it 0x squared. Otherwise, things are going to go wrong. For algebraic long division, the only thing you can guarantee is removing the first column. And you remove the first column by subtracting x squared worth of this. So you times this entire thing by x squared and you subtract it. X to the power of 4 plus 2x cubed subtract 3x squared. Subtract. First column disappears. X cubed subtract 2x cubed is negative x cubed. 0x squared subtract negative 3x squared is the same as addition. And you bring the next term down. Remember to keep track of the multiples you are subtracting by at the top. Need to remove the first column, you have to times by negative x. So negative x cubed, negative 2x squared plus 3x. Perform another subtraction. First column's got to disappear. Second column becomes plus 2, so 5x squared. X take away 3x is negative 2x. Bring the next one down. And then you have to get rid of the 5x squared, so that's going to be a plus 5. So you've got 5x squared plus 10x, subtract 15, perform a subtraction, and the first column disappears, and then you're left with negative 12x, negative 10, subtract negative 15 is actually addition, so that's plus 5. There's nothing left to bring down, so you know you are done. And the number at the top is the quotient, the number at the bottom is the remainder. And then you can say, in other words, f of x is equal to, or I could actually in this use the identity symbol, identical to, I could have used the identity symbol there and there as well, is identical to the quotient plus the remainder over what I was dividing by, x squared plus 2x minus 3. And that looks exactly like the form I was expecting. And in some of the questions you're going to be doing today, they'll require you to do one extra step and times by this denominator. Don't have to expand any brackets, but you would just times by the denominator to get the slightly disguised form. Right, the questions I'd like you to complete today are on page 16. And let's do the odds. And the odds only from exercise 1F. And that's it.